And the way I want to share this is to share these three stories, starting off with the work that I've been doing on what's called the learning map. And then I'll meander through to a story about what I'm doing on the doing map. And then I'll meander through to a story about what happens when you try and make plans and life has other plans for you. And that's how I'll tie them all together, and I'll finish off the presentation with what I'm doing now and hope to do in the future. So to start off, I want to start with the learning map. This project started about 10 years ago with the birth of my daughter. I wanted to empower her to learn anything that she wanted to. I wanted her to have control over the things that she learns and how she learns. The idea was simple. We wanted to, I wanted to take educational content and materials, games and apps and YouTube videos, things like that, and deconstruct them into concepts that can be learned, and then map them onto a learning map, and then string the pathways back together and merge it with all these other pathways that we've deconstructed, so that it becomes a pretty simple tool, but it would allow her to know where she's at, search for something she wants to learn, and then see all the pathways she can take to get to that point where she wants to go. But at this stage, my daughter was way too young, so instead I started working with kids in refugee camps and those that would never go to school, mainly in East Africa. And what was interesting here is these children didn't have access to teachers. And so if we could get this GPS for learning to work within this context, then theoretically it could work in any context. So I just want to share with you briefly how we went about this, because it ties into the other stories. And I think some of you would find this interesting. So the way we did this work was to take educational material like curriculum and YouTube videos and lectures and online programs and deconstruct them into concepts and content. And we separated the concepts from the content. So the concepts became these nodes, and the content we separated, but we tagged the content to the concepts. And once we finished deconstructing the piece of educational material, you would have in general these three parts. You would have the concepts being taught, you'd have the content related to the concept, and you'd have the links between them, which are the pathways that structure the learning. What we then do is we would extract the effort it takes for you to learn a particular concept. And that was important because we wanted to dynamically show where this concept should sit in a map. And I won't go into too much detail, but what is important here is a learning map is not like a Google map. A Google map is flat, two-dimensional. Paris and Lyon are always going to be. I said Google too many times. My phone is going off. So like in Google Maps, Paris and Lyon are always going to be where Paris and Lyon are, right? They don't move places. But in a learning map, we don't just work in two-dimensional space. We work in a multi-dimensional space, because a singular concept has relationships with so many other concepts. It's not a linear relationship. It has a web type relationship. And so dependent on what your question was to the learning map would change, because you're looking at it from a different angle, right? So in our case, the location of Paris and Lyon within the context of a map would always be changing dependent on the view that the learner is looking at the map with. And so that's what we did here. Once we deconstructed all the learning material, we wanted to match every concept with other concepts that we had already deconstructed. And so we matched them with referenced nodes. So these are concepts being mentioned within the concept you're learning, but this is a concept that isn't actually being taught, right? So we wanted to make sure that there's a connection there, so that when my daughter, for example, when my daughter is studying mathematics and she's busy learning geometry, I want her to be able to understand that this concept in geometry has a connection to ancient pyramid architecture, because she's interested in that, right? And so while she's learning her math, I wanted her to be able to see the context of all the topics around which relate to what she's learning. And this is why we did this. We also did the same with keywords, so that we can automate this progress through machine learning. We can look at what keywords are relevant or what topics are spoken about within concepts, and we can make those connections. And then once we've done that for a particular map, this is what it ends up looking like. You have the deconstructed pathway in the middle of all the concepts being taught in this particular course, or whatever the case may be, and all the related concepts being mentioned. I won't go into too much detail here, but we would then weight the different connections and weight the connections between the concepts based on the learning content. And you can think of this as almost like Google Maps when they look at when they try to give you a direction from point A to point B, they take into account congestion, and they take into account if you want to take service roads, or if you want to take highways, if you want to go there quick, or if you want to take the scenic route. This is the way that we determine this type of information. We give each pathway weights. And then once you've done that for a curriculum, you repeat that for all of the curriculum, or all the YouTube videos you do, or all the textbooks, and you go through a process of deduplicating or merging the maps. And you get to something that is a big mess, and you can't do anything with it, because I don't know if any of you have seen a graph database. They look really cool for data scientists, and it's all like, wow, this is awesome, but it's almost impossible for anyone to actually use. And so the question is, how do we package this? How do we make it usable to someone like my daughter, who's 5 years old, or was 5 years old? And the idea we came up with was, well, let's not show the map. Let's focus on what the query was from my daughter. So let's sort out all the concepts that relate to that query, and then let's put her in that center of that query and show her all the concepts in concentric rings becoming more and more and more complex. And then within this map, we can show her recommended pathways. She can learn her particular query. We can show her where her friends are at, if they are learning any of those concepts, and she can speak to her friends. And that's what we did. We built this cool little prototype. We were testing it out in East Africa. And this was all open source, which was all the work that I do is open source. And this was important, but I also struggled to get funding for this. But over the years, I joined a company called Guru, and what was to continue this work. And what was interesting here is that Guru was created by Dr. Prasad Gram, who used to lead the Google Maps team. And so he's now building a Google Maps for learning. And so the work that I was doing and his work, we've merged. He obviously has a huge team with him. And so this work is now continuing under the umbrella of Guru. But this only answered half of the question for me and my daughter. You see, I didn't just want to empower her to learn anything she wants to learn, but I wanted her to be empowered to do anything she wants to do. And this now brings us to the second story, which is the doing map. And the doing map we can think of as two sides of the same coin. So while the learning map was teaching my daughter how to learn all the things that she needs to learn, I wanted to also teach her how to do all the things she wants to do. And these are, you can think of these as two sides of the same coin, where on the learning map, we are mapping all the things you can learn. And on the doing map, we map out all the things you can do. And the link between the two is your qualification, your accreditation. If you're able to learn the thing and you're able to apply that learning, you obviously have a qualification for that. And so how do we go about building the doing map was the question. And the doing map is built on the same technology and it has the same core structure, right? So if on the learning map we had nodes and these are the concepts that can be learned, then on the doing map we have a open source project and these are the parts of the project which we call bricks that you have to build. So a brick could be a business model, it could be a piece of software, it could be a piece of technology, it could be a marketing strategy. These are the bricks that make a project work. And on the learning map, we would tag content to the concept being taught. But on the doing side of the map, we would tag artifacts to the project being built. So if it was a business model, we could attach various business model strategy papers or spreadsheets or P&L statements, things like that. If it was a piece of software, we would attach GitHub repositories, or we would do attach libraries, or whatever the case may be, right? And the third is, on the learning map, when you string pieces of learning together, you create a course or a learning path. On the doing map, when you string projects of these bricks together, you create a project. You create something that does something that has a particular input and produces a particular output, right? So the learning map and the doing map are structured very, very similar. And what this would allow us to do is for my daughter to now start to ask the same type of question. Well, how do I build the thing I want to build? And now using the same technology, we can show her all these projects that are doing the thing that she wants to do. And we could show her where she's at on her learning. And we can see all the concentric circles of complexity moving out and the projects that can be built within her query. So the idea here is she would be able to see the work that other people are doing and how they are doing that. She would see open source projects and all the rest of it. But the question is, how would we go and create that doing map? Now, in the learning map, we deconstructed educational material. So on the doing map, we would deconstruct open source projects, like the projects on GitHub or in project-based learning programs within schools, where students need to work on projects. If we could deconstruct those and put them on a map, then anytime a student wants to build a new project, they can search the map, they can take pieces of that map and say, you know what, I'm going to take this and this and this idea, I'm going to reconstruct them, recombine them, and create my own idea. Or potentially they can take an idea and say, okay, this project worked in East Africa, I want to now make it work in India. So I don't need to make too many changes, I can just localize it to make it work in India. Or potentially, I have this idea and this idea, I'm going to squish them together and merge and make something new. And the hope was that if we can get students to use the learning map, to use the bricks to create something new, and then to share their projects back to the doing map, that this would create a positive feedback loop and rapidly accelerate innovation and projects and open source projects. But the question is, why hasn't this positive feedback loop worked previously? We have lots of open libraries or projects like GitHub and Hackaday.io and OpenIDEO and Ideation. All of these libraries have open source projects. So why aren't we seeing this rapid acceleration of innovation? And I think it comes down to 3 key points. One is we need a blanket frictionless open license, an open share-alike license, a singular license which is open and share-alike. As soon as you start to add more than one license, the cost, the transaction cost becomes exponential. If you have a singular license, then the transaction cost can be handled within the network. And as an individual, you don't need to worry about it because you know the rules of the game. And so we need a singular open license. then we need a framework, an interoperable framework to make these projects work with one another. I won't go into too much detail, but I've written about this extensively. We need an interoperable framework which makes these bricks easily used by other projects. And then thirdly, we need an incentive mechanism, some type of mechanism which makes sense for us to share our ideas openly and share them openly with the ecosystem and have it being used by the ecosystem copied. So there's the incentive mechanism. I won't go into interoperability and incentive mechanism here, but these are the three things we definitely need. And now just a side note, why is this all important? I think it's important because we have such a huge number of global challenges, like mentioned in the Sustainable Development Goals. We somehow need to rapidly accelerate the innovation that we are producing to meet the needs of these global challenges. And I think the only way we can do that is through open innovation. And the reason why I think that's only possible through open innovation is by looking at the difference between open and closed innovation. So let's do that quick. Within closed innovation, usually you have this great big idea, right? You usually have this yourself or maybe in your company. You then work you go through a design loop, you work and you make this idea really good. Maybe you get to product market fit and that becomes a success. But it's at this stage that the innovation stagnates, because once an innovation hits success, the innovation then only focuses on incremental improvements because it doesn't want to destroy its business model. And so innovation stagnates very, very quickly. So let's look at the difference between that and open innovation. Within open innovation, you not only have your big idea, but you see everybody else's big idea. And so even before you start, you can pick and choose from other people's ideas and learn from them and start with not just your big idea, but with everyone else's. And then the cycle is very similar. But here at each stage, again, you have the ideas of the whole ecosystem. And at each stage, the ecosystem can copy and fork your project and do something completely different. So you have a singular idea being forked multiple times, and all these people are trying different avenues to make it a success. And then if someone else makes it a success, you can pull that back into your project. And what this allows us to do is to rapidly produce successful innovation and more of it. And then one last point is that if we take all the global challenges and if we chart them in a chart and we look at the severity, it follows a power law distribution where the top 20% of the world's challenges create 80% of the issues we have. And it's this 20% of challenges where we can create business models to solve them. It's really easy to create business models to solve the top 20% of the world's challenges, right? People want to fund renewable energies, for example. There is money there, but there's a whole section of problems, this bottom 80%, where it's almost impossible within the current climate, the current economic climate, to produce sustainable business models to solve these. And so these are key challenges. So those were just side thoughts. So anyways, building the doing side of the map is a huge project, and I couldn't do it on my own. And so I started working with a bunch of other folks around, and now together with Guru as well. And this was all going very well until life happened. And over the course of just a few hours, my daughter suddenly became paralyzed. She suddenly became paralyzed. She was sent to the hospital, and she was almost completely paralyzed. And the doctors didn't know what was happening, but she, over the course of a few weeks, she became better. But her left arm was completely paralyzed. The motor neuron damage in her left arm was permanent, and the doctors said that, it's very, even though she's young, it's highly unlikely that she will use her arm again. So my daughter and I were in the hospital bed, and now suddenly she had this project she wanted to do. She had this intrinsic motivation to do something, to build something, right? And so while we were still in the hospital, we started to research what options are there available for us. And we looked and we found these projects, and some of these projects were really interesting because they were building exoskeletons, brain-controlled exoskeletons that were teaching paralyzed people to move again. And because they were using brain signals to actuate the exoskeleton, it was training the brain to continually send signals, even though the motor neurons weren't working, which in the end encouraged those motor neurons to regenerate. And so we thought, okay, this is awesome. Let's do this. Let's try do this. So we reached out to these projects, but they were all closed. None of them wanted to share what they were doing with us. And the ones that did want us to work with them, they were thinking of charging us up to $100,000 to take part and use these devices. And we didn't have money for that. So we decided to try and build our own. But we had no idea what we were doing or where even to start. So the question was, would we be able to build the learning map to teach us all the things we needed to learn? Would we be able to tap into the collective intelligence of the world and try to get them to tell us all the things that we need to learn to build this exoskeleton? And then would we be able to build a doing map to build all the things we needed to build? Like the actuator and the 3D printing of the exoskeleton and the electronics and the machine learning that needs to go into it. Would we be able to do it? Our assumption was obviously no, but we went ahead and we created questions. We asked people questions related to the learning map and the doing map, like how do we learn X or Y or Z? How do we build X, Y, or Z? And within weeks, we got people all around the world to help us do this and help us build both the learning map and the doing map and bring everything together. And so every day we started to build and work on this. And we came home from school, and instead of doing homework, we actually worked on this. And we started to learn all the things we needed to learn. We started to build all the things we needed to build. And in the end, over several months, we built this brain-controlled exoskeleton, which allowed her to use her left arm. And I encourage you we have some YouTube videos of a story where she's presenting this whole thing. I encourage you to watch it. It's really, she's wonderful in it. But what was really cool about this is not only did it work, it also did something we couldn't dream of, and that is it regenerated her motor neurons. She's now able to use her left arm. She's regained about 40% of the strength. Her shoulder's still paralyzed because we haven't been able to build anything for her shoulder, but that is an open source project, and there's people helping us do that. But this is just one example of what's able to be done when we openly share everything we learn and everything we do. And what's interesting here is that this project is one of those projects which lies within that 8% curve, right? This is a perfect example of what can be achieved when we openly share everything we learn and when we openly share all the things we do. It's in this area that open innovation really accelerates, and we're able to do things. And so that's my work now. Is I want to work on projects that openly share all the things that we can learn on the learning map, and then share all the things that we can do on a doing map. And I'm working together with a number of organizations to do that. And I just wanted to share with you now quickly where we are today. So we're working on two layers, the foundational layer and the tools layer. On the foundational layer, this is where we are building the various maps. And so far with Guru has mapped out most of K-12 math and science. They've started to map out, we've started to map out skills training, some professional training, early literacy and numeracy, English, and then a whole bunch of early literacy and numeracy in India as well. So those are the maps we have today. So they are pretty focused and pretty small, but that's our start. And on the tools layer, we built these really cool GPS-like tools. And we have these 8 different tools. And so it's a tool, it's tools for students and for educators and for curriculum designers and for researchers to use. And we've had some pretty good growth on these tools so far as well. Where we hope to go, or what we're working on now, is to map out the rest of education. Can we map out all of education? Can we map out everything from pre-K to PhD level material from all of the open educational resources that we have around us, including YouTube videos and textbooks and everything else? Can we map those out? And in order for us to do that, we're creating open source tools so that anybody can join us in that effort. Up until now, it's mostly been Guru, as well as a couple of collaborators building this map. But we want to give this tool freely and openly to anyone. And so we're building open source tools that will allow anyone to start mapping out educational content and their projects and their program-based projects, so that we start to rapidly build the learning map and the doing map. And the hope is that one day we'll be able to map out all human knowledge, so that you can learn anything you want to through this open, freely available tool. And on the tools layer, we are building it in such a way that the components of the tools we're building are actually bricks on the doing map. So that, we have our own ideas of what works as a GPS for learning, but you may have far better ideas. So we put it on the doing map, and the idea is, well, you can take these bricks and create something else and create something more powerful than we can. And so hopefully that drives even further innovation within what we're doing. And I will leave it there. If you want to learn more information about those, you can find it on DefRex and guru.org. And then I will leave this thought with you, that assuming linear growth in these maps, we could expect to exceed the complexity of the human mind by 2030. Yeah, so I'll leave it there.
Okay, thank you very, very much, Bodo.
Thank you.
So for me, it was very clear and interesting. So feel free now, guys, if you have questions. I'm sure you have.
Yeah, okay, thanks. Well, it's very, very dense and very mind-blowing, actually, since I have so many questions that I think I will maybe, if you allow me, route you. I will write you the thing I want to ask, but maybe I just can try with one. I was wondering about the semantic web, because I think that the semantic web is a way to map knowledge as a graph.
Yeah.
Do you imagine some kind of plugs between your Guru knowledge representation and the semantic web?
That's actually a really clever, really good question, because
yes, thank you very much.
Because if we only map out educational curriculum and courses, we get a very biased view of how learning is structured. And the reason I know it's biased is because I was working with this school that was teaching music, but they were using famous musicians to teach their curriculum. And these famous musicians thought that the curriculum was pretty good. They liked the curriculum. They thought it was very well structured and everything. But then as an experiment, and I didn't tell them what I was doing, but as an experiment, I interviewed them and I asked them, well, how did you learn? How did you become a musician? You know, tell me the story, you know, from where you first were introduced to music to where you are now. And they thought I was just interviewing them as like to write an article about them. But every answer they gave, I wasn't looking at what they were saying. I was looking at what concept is he referring to. And then I wrote that concept down, right? And then every time I asked a question, like, why did you learn that? Or what did you go? What did you learn next? What did you do? So now I have all these concepts that they learned. And now I have this string and I try to match it with the curriculums we're teaching, and nothing matches, right? You have these top musicians doing amazing stuff in music, but none of them seem to follow a good curriculum. And in fact, if I look at some of these curriculum, they are terrible, right? And if I look at some of these way that people work, it's all over the place, right? They're going from drums to music production on digital devices, back to guitar, back to vocals, or going off the beats and trail totally. How does that match? And so you raise a really good question. Is we need the map to be built from educational material, one, but we need to also have the same map being built by the semantic web, or we think of Wikipedia as being a really good ontology of human knowledge, right? It has a structured human knowledge, and it's a pretty well ontology in that a lot of people are keeping it up to date. I mean, there's issues with it as well, but it's a pretty good basis. But Wikipedia doesn't really have directionality to it. It doesn't really define the pathways, but it does have a structure, right? It allows you to link geometry to ancient pyramid construction really well, right? You're able to make those ties pretty well. So we need to use those two methods to build a map. But the third method is, and this I think is the most important, is the fundamental structure of the map needs to emerge. It's not something that we should build ourselves. I think we should build a system within which that structure can emerge. So we shouldn't hard code subjects, for example. We shouldn't hard code pathways. We shouldn't hard code anything. We should allow those to emerge. And I think it's a really good question because it shows me that you've already made that connection. Thank you.
If I can ask you a question, Bodo?
Yeah.
If I remember well, when hearing the story about your daughter and her arm, I'm not sure, but I guess I remember there was a question of signal processing with difficulties due to the noise of the sensor. So you used a bunch of sensors to extract the fusion of signal, and it works this way. And it was an innovation because classic engineers didn't do that before, right? Am I right?
Yeah. Can you see the screen?
Yes.
So the idea was, we were trying to use traditional muscle sensors to pick up the signal from the muscle, because about 2% of the signal was still getting through to a muscle. So the signal wasn't strong enough to actually move the muscle, but we wanted to be able to pick that up so that we can encourage her brain to continually send signals there. And so we tried to use traditional muscle sensors because they worked really well on my arm. And So this is what the signal looks like on my arm. And so this is what the signal looked like on my arm. And then what we could do is we could normalize that signal and then add a threshold to it so that whenever the signal gets to a threshold, we could, pull the arm up and down. When I pull my bicep, it senses the signal and pulls the arm up. And so this worked really well on my arm. We could control this robotic arm pretty well. But for my daughter, her arm signal looked like this. You could barely make out that there was a difference between when she was relaxed and when it was active. And if we put a threshold onto this, the actuator would be triggered randomly by her finger twitching or whatever the case may be. And so we thought maybe we could increase the amount of information we use by using machine learning and by strapping as many sensors as we can possibly fit around her arm. And a company called Coapt helped us with this. And this was actually pretty good. So here you can see that we've got as many sensors as we can around the arm. We've programmed the control unit with machine learning to pick up 3 different types of signals. So she's not actually able to move her arm, but we're picking up enough signals that it's controlling the virtual arm or the robotic arm. Yeah, it was a really cool problem to try and solve.
Okay,
Right. Thank you,
stay
Bodo.
in touch.
Salut.
Thank you.
Thank you.
Thank you, and goodbye.
Bye.
Goodbye.
Goodbye.